Now let's see this approach followed by Solaris 2. Solaris 2 is a version of Unix and it is using threading concept, and then the threads, it is actually using two types of threads. One is user level threads and the kernel level threads. So in the kernel level threading, I told you that kernel is aware of the threads, but then there is other kind of threads which are used to execute the task by the kernel itself, right? So if you see this, you'll understand this model. Now in this one, they are calling separately some threads as kernel level threads. So assume that this is the kernel, okay, this is the CPU, this is the kernel, which means operating system code will be here, and this is the user process, right? Let's call it as a task. So this one is a task, this rectangular box is a task, this one is a task, and this one is a task. And whatever these symbols you see here, they are all normal user level threads. In order to create these user level threads or to switch between these user level threads, nothing has to be done, right? Therefore, nothing has to be done means no kernel action is required. Only the library, user level library is involved. Therefore, no kernel services are required in order to switch from one user level thread to other user level thread. So all the advantages of user level threads are present in this concept, right? And then every thread, every user level thread, if it has to run, it has to get associated with something called as lightweight process. These circles whichever you are seeing, they are called as lightweight process. So to our operating system, it doesn't know anything about the user level threads, but it will know only about the lightweight processes. For example, this particular task, it has got two lightweight processes, right? And it has got only one lightweight process, and this has got three lightweight processes. So for the operating system, it can see that each task is containing many lightweight processes. Therefore, operating system will try to schedule the lightweight process not directly but indirectly by creating a kernel level thread. And now this kernel level thread are just like the same things that you have seen in our earlier concept, but then they specifically execute the code that is written inside the kernel, which means these threads will execute the programs which are present inside the kernel. So understand this, for every user level thread there has to be a lightweight process, and for every lightweight process there has to be a kernel level thread. Got it? Now a lightweight process can have many user level threads, but a kernel level thread should be associated with only one lightweight process. Got it? And all these kernel level threads will get time from the CPU. Got it? CPU will schedule, let us say, this kernel level thread first. Assume that it is being scheduled. Now this kernel level thread will make this lightweight process to run, and now this lightweight process, when it is scheduled, it can schedule either this thread or this thread or this thread. Now what thread is running among these three user level threads, that depends on the task, right? Whatever you want to run, you can run it, and you need not take any permission from the kernel level thread. But then when switching from this kernel level thread to this kernel level thread, again some work has to be done at the level of operating system. That is why they are called as kernel level threads, because our operating system is aware of these threads, right? And these threads are aware of lightweight processes, and these lightweight processes are aware of this. Therefore, this is a hybrid model in which both the user level threads and kernel level threads are being used, and we are also going to have lightweight processes. Now let's talk about switching. If you want to switch from one user level thread to other user level thread, there is no need of system call at all. Therefore, it is fast. If you want to switch from one lightweight process to other lightweight process, it has to undergo some context switching. Therefore, certain certain system calls are involved in this. It is bit slower. Similarly, when you want to switch from here to here, again some more work has to be done. So switching between user level threads is very fast. switching between these lightweight process is slow, and switching between these all is also slow. Once you switch here, they will be switched. Got it? So in order to create a new user level thread, no work has to be done from the kernel, right? So all the benefits of user level threads are there, as well as all the benefits of kernel level threads are also there. So how is it beneficial is, just think about this scenario. Let us say this particular user level thread, when it is executing, has asked for the IO services, let us say like a hard disk, and it got blocked. If we don't have kernel level threads, then what happens is the entire task, it generally gets blocked. But in this case, since we have the kernel level threads, since we know that it is that there are many lightweight process executing, whenever this user level thread gets blocked, this lightweight process gets blocked. And when this lightweight process gets blocked, see, I already told you that thread is also called as a lightweight process, but in this case, this is a practical scenario. In this case, they are using this special name called as lightweight process, not for the thread, but for this one itself, right? Now, if this one gets blocked, our lightweight process gets blocked. If our lightweight process gets blocked, this thread gets blocked. Got it? Therefore, finally, this one will get blocked, but then the entire task will not get blocked, because when this particular thread is next scheduled, then this particular lightweight process will be scheduled, and this particular user thread will execute. Therefore, we are having the benefits of lightweight process, which means this user level threads can be created and then switched without the involvement of kernel, and also we have got the benefits of the kernel level threads. So which means if one thread got blocked, our entire task will not get blocked. So that is how this particular operating system is using a combination of this. It is called as a hybrid implementation. It is using the combination of both user level threads and kernel level threads to achieve this. Okay, so that is all about the threads. So anyway, you need not read about this one. In general, you can read about the threads which I have provided in the previous two videos, and this one is a case study which is not very important, since it is there in the textbook. I explained you. So in case if they ask, let's see, but don't by heart it. Okay, fine.